Okay, ladies and gentlemen, welcome to Math 10C Chapter 2 review. Now, we've done all this repeatedly. I'm just going to hit the high points here. And remember, if you're having trouble, please stop and look at the lesson again. Now, right now, all these formulas should be written on your formula sheet. Now, I'm going to refer to them occasionally because I'll be darned if I can remember them all. Anyway, so hitting the high points, first question. What's the tan ratio of angle A? Now, what is tan? Tan of theta is opposite over adjacent. If this is angle A, what is the opposite side? Well, this is the opposite. This is the adjacent. This is the hypotenuse. Okay? So, the tan ratio is the opposite, 7 over 11, over the adjacent 11. Okay? That's it. Now, what's angle A? I'll go back here. Tan, angle is inverse tan of opposite over adjacent. I get 32.4 degrees. Let's go to 1 decimal place, okay? Now, for my crude drawing, that seems pretty reasonable. So far, so good? And the ratio versus the angle. Now, if you get a few of those, you'll use sine to find this or whatever. This is the more interesting and more common question. Solve this triangle. Now, here you got to go, what's Mr. Sutton talking about? Solve. That means find the missing sides and angles. So this is side F, opposite angle F. That's a poor color. Let me change that to something a little more noticeable. Yes. This is side F, opposite angle F. This is side D, and this is side E. So we have to find angle E, side D, and side E. Now, this is side F is the hypotenuse. We have one angle D, which makes this the adjacent, and this is the opposite. So, what do we solve for first? Well, arbitrarily, I'm going to solve for angle E, because I know the three angles in a triangle 180 degrees, they equal angle D plus angle E plus angle F. And yes, show snaps. Angle D is 72 degrees. Angle E we do not know. And angle F is 90. So, angle E is 18 degrees. Good. Now, we need to solve one of the sides. If we had two sides, we could use Mr. Pythagoras. I'm not going to use him today. I'm going to arbitrarily do the adjacent, because I can. Now I have adjacent and I have the hypotenuse. Double checking. Adjacent and hypotenuse is cosine, right here in the middle. Adjacent equals hypotenuse times cos theta. So in this instance, the adjacent, I don't know, but the hypotenuse is 21 centimeters times cos of 72 degrees, which is 21. Oh, sorry, cos of 70. Mr. Calculator says cos of 72 is 0.3090 is 6.489 blah 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 blah, which is 6.5. Now that's E. So side E. I should be calling that E. Now, finding side D. You'll notice here, quite often there's more than one way. As I said, we now have two sides. We can do Mr. Pythagoras. I would rather do, instead of Pythagoras, just because we might have made a boo-boo with side E, not use the 6.5 in any more calculations, but go back to the trig ratios. I've got hypotenuse and opposite. Now, opposite, or hang on, this is D, which is opposite. That's hypotenuse times sine theta. And I double checked that because God knows I made that mistake enough. Opposite hypotenuse sine theta. Yes. Okay, so plugging the numbers in. 21 centimeters. Sine is 72 degrees. Zero 0.9511. 19.97 2 equals 20.0 centimeters, which is D. And I should call this centimeters because that's not an angle. All right. So that's how we solve that triangle. Are there other ways? Certainly. This is just one way. Now, as I expect you guys to be checking my work as we go along, doing the calculations as I do them, make certain I'm getting the correct numbers. All right. Moving on. Perimeter of this triangle. All right, now notice a slight difference. It's not solve, it's perimeter. I like these questions. I could ask, what's the area? Area is half the base times the height. In this case, I'm asking perimeter, so we have to solve for side x and side y. Now, I'm arbitrarily going to solve for side y first because I can. Now, this angle is 20 degrees. This is the hypotenuse. This is the adjacent. And this is the opposite. So I have opposite and hypotenuse. And opposite equals hypotenuse sine theta, and I'm double checking that. Opposite equals hypotenuse sine theta, yes. So here's the problem. 6 equals the hypotenuse. I'm going to call that y times sine of 20 degrees. Now, sine of 20 degrees is 0.34202, rounding up to 4 decimal places, is that. So, how do we get rid of times 0.3420? Yes, we divide both sides by 0.3420. So y is 17.54, which I'm going to round off to 17.5 centimeters. Now, once again, you could use Mr. Pythagoras to find side x. The problem is we might have made a boo-boo, so let's not use the 17.5 unless we have to. Okay? So, we know the opposite, and we want the adjacent. Opposite and adjacent is tan, and the formula is opposite equals adjacent times, wrong, sorry. Why did I write tan there? That's what, oh. God help me, I'm getting old. Thank you for pointing that out earlier. Oh, God. So I screwed that up in lesson 7. Oh well. Opposite equals adjacent times tan theta. Oh, mother of God. God bless cut and paste. Did I get it right this time? I hear you laughing as you giggle at me. Yeah, you just wait. Someday you'll be old like me making these dumb mistakes. And I'll just sit there and laugh and laugh and laugh at you, and I won't know why, but I will laugh and laugh at you. So 6 equals x. Now tan of 20 is 0.36 397, which rounds off to 340. Now, how do we get rid of times? 0.3640. We divide both sides by 0.3640. Oh, Yusha is about to stop that. People are watching. So side X, 16.48, which rounds off to 16.5 centimeters. $16.48. So add them up. Plus 6 centimeters plus 16.5 centimeters comes out to be 40.0 centimeters. All right, so that's how you find the perimeter. Could you have done it other ways? Yes. Do I care? No. So, another favorite question, more than one triangle put together. Woohoo! You remember these. Now, first things first, we have to figure out the purple triangle, because that's the information given. For the purple one, we have this angle, so this is the hypotenuse, opposite the right angle, and this is the opposite side. Okay, so we have to find the hypotenuse. Oh, I'm sorry, this is the adjacent side. So adjacent hypotenuse. That's cos theta. Now let me double check that one, because God help me. Yes, adjacent hypotenuse cos theta. So the adjacent, actually I'm going to stop, I'm going to pause the recording here. You guys tell me what the hypotenuse is, and then realize that's the hypotenuse here, and this is the adjacent side. So I'm going to pause the recording. We'll come back, compare work, and see what answers we get. Okay? Okay. So 3.4, the hypotenuse times cos of 59 degrees. 3.4 equals hypotenuse cos of 59 is 0.5150. And we have to divide both sides by 0.5150. .60 centimeters. Now remember, we're using this number in another calculation, so don't round it off. I'm just writing 6.6. You leave it on the calculator, 6.6014539. Use that in the next calculation. All right? Now, in the next calculation, we have to find the adjacent side, and we have the hypotenuse. Oh, we use the same formula again. Adjacent is hypotenuse times cos of theta. Now, the adjacent is side x, the hypotenuse, 6.6. I'm writing it as 6.6. You use 6.6014539 in your calculation, or I will scream and throw things at you. I mean, be unhappy. Cos 42 degrees. That is 0.737431. And no, I'm just rounding it off to 4 decimal places. You're using all 8 in your calculator times your answer. And you're getting x is 4.9058, which rounds off to 4.9 centimeters. That's what I'm looking for. Now, on the chapter test, I would, well, depending on my mood, I might accept 5 or 4.8, but that could be a rounding off error. You have to be careful there. Okay. So far, so good? Good. Now, moving on. stop being that guy. People are watching. Now, word question, just to screw with you. You're designing a wheelchair ramp for the stage at Roland Michener Secondary School. How long is the ramp if it rises 1.2 meters and has an incline angle of 4.8 degrees? Big question mark. Never mind. And I can't blame Microsoft for that, but I will. Okay, so first things first, notice word question, no picture. You guys have trouble with these. So what's the first thing you do? You draw a triangle. All right, now you start labeling sides. Wheelchair ramp. Okay, it rises 1.2 meters. Okay, so that's the height. Incline angle, angle of inclination, 4.8 degrees. Now, right off the bat, I think I've drawn a sucky triangle. As you notice, I sort of kind of try to draw them to scale. That is, roughly the correct size. So I find it useful. Now, I'm going to fix this because there's no way that's 4.8 degrees. 4.8 degrees is like a door wedge. That's more like 4.8 degrees. That's still too small, but it gives you the idea. Now, what is the question asking? How long is the ramp? Now, I admit right off the bat, that's poorly worded. I think they're talking about the hypotenuse here. All right. Yes, you can make an argument about the, should label them. This is the adjacent side. It's the hypotenuse. That's the opposite. We could make an argument that they're asking about the adjacent side, but I think from the wording, it's actually badly worded asking for the hypotenuse. Now we can argue about that, but since I've said it's the hypotenuse, we're not going to argue. Okay, so pause the recording, tell me what the hypotenuse is, we'll come back and check. Okay? Okay, ladies and gentlemen, welcome back. I solved it, and I got the hypotenuse as 14.3 meters. Now, that's really long, but if you ever looked at a wheelchair ramp, you realize they're quite shallow. So, now that's basically it for review. I will point out there's one more question I was going to talk about. Here, how tall is the bigger building? But we've done a bunch of these in class. Actually, I'm going to pause the recording. I'll do it, and we can come back and check our answers. Okay? Just check. All right? Okay, ladies and gentlemen. Now, quickly looking at this, as I did in class, I split it up into two triangles. The purple one, because we know this opposite side is 18. And I found, doing a little math, I found the adjacent side to be 21.4. Actually, 21.45156467. I'm just too lazy to write it all out. You don't dare erase it because Mr. Calculator will do it. There it is. Then I have to find this opposite side here. The opposite is 5.7 meters. Added the two numbers together, and I got 23.7 as the height of the taller building. All right, so that's it for Chapter 2 Trig. You see the same equations over and over again. When do you use which equation? Keep practicing. You've got enough review questions there. If you've got questions, ask. If not, good luck.